Hello students, now we are in the third experiment. Previously we have completed already two experiments. They are resistance per unit length of the wire and resistivity of the material of the wire. Now here is the turn, we are entering into the third experiment, that is comparison of the EMF of the two cells. Students, you will be provided with the two cells whose EMF it will be written already on the cells. You need to get a ratio of it by finding the balancing lengths. We need to calculate the two balancing lengths and we need to divide it such that the ratio of those lengths should come same as that of the ratio of the two EMFs. Means the ratio of the balancing lengths will be same as what the ratio of the EMF of the two cells. So these things we are going to see in the procedure. Okay, next. So let us start this comparison of EMF of the two cells. The aim is to compare the EMF of the two cells provided to you, and what all apparatus we are required is basically this comparison of the EMF of two cells experiment based on potentiometer setup. See here potentiometer setup, like actually we know already meter bridge, right? In a meter bridge we have 100 centimeter wire, that is 1 meter single wire we have, whereas in a potentiometer, like it is also the advanced, it is also nothing but advanced meter bridge I can say, with more length meter bridge. So in the potentiometer setup or in a potentiometer there will be a 400 centimeter wire. In meter bridge normally 100 centimeter wire will be there, in potentiometer 400 centimeter wire will be there. So basically I can say this is 400 centimeter meter bridge, that is same as what potentiometer. Okay. So the apparatus required are potentiometer, battery, given two cells, galvanometer, two-way key. In the previous experiments we have used one-way key, here we are going to use two-way key. Okay, so little bit odd one to understand, but I will show you how two-way key will look like. Then we have a rheostat, last we have what, a one-way key or a plug key. Let us go with the principle, like what is the principle behind in this experiment, like while comparing the EMF of two cells by calculating the balancing lengths, what principle is involved in this setup. See, basically we are using a potentiometer setup. In that potentiometer, when a steady current flows, in a wire, the potential difference between the 2 points, listen properly, when a constant current or a steady current flows in a wire, the potential difference across the two ends or 2 points of the wire is directly proportional to the balancing length, balancing length of the wire. Okay. So this principle is involved in potentiometer, and this potentiometer is extended meter bridge, okay, where 400 centimeter wire we are going to use. So that is what I have written here. When a steady current flows through a conducting wire of uniform thickness, potential difference between any 2 points on it directly proportional to the length of the wire between the 2 points. Okay. So the formula which we are going to utilize is the ratio of EMF of the two cells is going to be E1 by E2. E1 and E2 are the EMF of the two given cells, which should be same as L1 by L2, means EMF is directly proportional to the length of the wire. Students, you might be knowing what do you mean by EMF of the cell. See, freshly you get the cells from a market, whatever the voltage value they have written on it, it is nothing but EMF I can say, because once you use that cell in your circuit, the current will be drawn, okay, the current will be drawn from it, it will lose some voltage value. At that time it will be no more EMF, it will be some voltage value at that time. So EMF I can say open circuit voltage. Okay. So EMF, when no current flows in a circuit, the given EMF, when no current flows in a circuit, it means what? You are not drawing any current from a cell. Okay. So basically EMF is the potential difference between the 2 points when no current flows in a circuit. We have learned already in the theory part in the third chapter, that is current electricity. So important to understand. Just go to market, bring some cells, there suppose 3 volt is written. That 3 volt will indicate EMF because you are not using in circuit right now. Once you connect that cell in a circuit, at that time if you connect some voltmeter and if you want to check like now what is the voltage of given cell. At that time it will be no more 3 volt, some voltage will be reduced because some amount of current is utilizing in a circuit. Because of that cell is going to reduce its voltage value. Okay, it will be less than 3 volt at that time. Okay, so the main thing you need to understand, EMF is like open circuit voltage. Okay, so remember that. Now the ratio, this ratio is going to match with the ratio of EMF. This will be provided to you, and hence we are going to compare with L1 and L2. What are these L1 and L2? E1 is EMF of the first cell, E2 is EMF of the second cell. L1 and L2 are balancing length of first cell and second cell. Okay, we know already what do you mean by balancing length. Balancing length means the length of the wire at which galvanometer shows 0 deflection. That length we are going to call it as what? Balancing length. Here when no current flows in a circuit, that means when a current is when the current through the galvanometer is 0 or galvanometer showing 0 deflection, we are going to calculate the balancing lengths. Okay, this is what the formula. Now let us proceed with the procedure. Hope you have understood this. Just have a look over it once again. Just aim comparison. Apparatus I have written, principle of the potentiometer and formula. If they ask what is the principle in your like external exam, so you need to tell the principle of potentiometer. Here I have written principle of potentiometer. So in potentiometer you will be having 400 centimeter wire, and when a constant current flowing in a conducting wire, the potential difference is directly proportional to the length of the wire. You need to tell this, and tell one more thing, that it is extended version of a meter bridge. Okay, or we can say Wheatstone bridge. Hopefully we have understood this. Now let us proceed with let us proceed with procedure. Okay, now let us know about its procedure. By like we are learning the experiment of comparison of EMF of the two cells. Let us understand its procedure. Here I have written the procedure. Just let us read this. After that I am going to explain. So look at here. The circuit connections are made as shown in the figure. The key K is closed and the two-way key, look at here, this key means one-way key is first closed and the two-way key is connected to the cell E1, and the circuit is checked for opposite deflections by placing jockey at the two ends of the wire, that is PQ alternately. The jockey is moved on the potentiometer wire from the P towards Q till the galvanometer shows 0 deflection. The balancing length L1 is measured. First, initially when the key is closed and the two-way key, if it is connected to cell E1, means if we are from the two-way, if we are using the wire which is connected to E1, we need to calculate the balancing length L1 first. That is what this point indicates. The balancing length L1 is measured. Then the two-way key is disconnected from the cell E1 and now it is connected towards cell E2. Now once we connect the two-way key to the cell E2, the balancing length L2 is measured. Hence, we can calculate the ratio of E1 by E2 from the formula, like E1 by E2 is same as what? L1 by L2. So just now we have seen the principle of what? This potentiometer. What was that? The EMF of the cell is proportional to the length of the wire. So that is what E1 by E2 ratio is going to same as L1 by L2. The experiment is repeated by shifting the contact point of the rheostat and average value of EMF of the two cells is found. Okay, here just observe this. I am going to explain once again with the help of circuit diagram. So the main thing you need to understand, once the circuit is completed, first from the two-way, at one rheostat position, we are calculating the length L1 and L2 by shifting the two-way key towards E1 and towards E2. For one rheostat position, L1, L2 is measured. Next, for other rheostat position, again L1 and L2 is measured. So this is repeated for only 3 readings. Okay, so let us proceed with the circuit diagram. Okay, now just now we have seen the procedure. Now let us start how this actually works. Students, here we are going to have the circuit diagram for your experiment of comparison the EMF of two cells. Look at the circuit diagram. Here E1 and E2, these are the two cells. Okay, the cells you will be provided. Normally we use the cells in remote control, everywhere, like in watches we are using, everywhere we are using, right, cells and all. So that cells EMF we are going to compare in our experiment by using potentiometer setup. Okay. So these are the two cells, okay, whose EMF we are comparing and finding its balancing length. Look at this, these are two cells E1 and E2. This is a battery, okay, this is plug key, a rheostat. This PQ and this wire will indicate potentiometer. As I said you, meter bridge will have 100 centimeter wire, potentiometer will have 400 centimeter wire. So its end point from P to Q, its length is 400 centimeter, whereas in meter bridge it is 100 centimeter. Okay. So PQ indicates a wire in the potentiometer, G is a galvanometer, this point C, this indicates what? Jockey indication. Okay. So this is what this part indicates, primary circuit, this secondary, this part indicates what? Secondary circuit. Now let us understand how we have to proceed this experiment. Students, first switch on means plug in this. Once we plug in this key, like the circuit will be completed. Later, here we have a two-way key. Students, this is two-way key. Here we have a two-way key. Here we have three knobs, you can see here. Okay. So here we can use either this part or this part at a time. Right now I am using this, will act like one way from the two-way key. Okay. Like if I connect the connection of galvanometer to like one to this first part. Okay. I will show you while doing the experiment. Now the first part is connected to this. Okay, we are using the connection from the cell E1. Okay, this galvanometer connection is connected to the here E1 side. Once the circuit is closed, now the key is closed towards the cell E1 and find out the length L1. Remaining length is 100 minus L1. Okay, once the two-way key is connected towards E1, find out the length L1. What is the balancing length L1? What do you mean by balancing length? The length of the potentiometer or the meter bridge or the wire where the galvanometer shows zero deflections. Once we are connecting the circuit towards cell E1 from the two-way key, we need to calculate the balancing length L1. The procedure will be simple, like we have to move the jockey, like first we use this key and by closing this and by closing this towards the cell E1, we are calculating the length L1, means we are going to calculate the balancing length L1. Okay. So for one rheostat position actually, so I am going to repeat this once again. See, circuit connections are as shown in the figure we need to do. By closing the key and by setting rheostat at one position. By setting rheostat at one position means for some resistance we are keeping this rheostat position. Once these two things are done, connect this two-way key towards cell E1 and measure the balancing length L1. How to measure the balancing length L1? While moving the jockey over the wire, when the galvanometer shows zero deflection, measure that length L1. So once that is done, you are going to write the reading L1. Later, this key is connected towards where? E2. Later, this will be connected towards where? E2. Now the two-way key, this key is connected towards cell E2. For the same one rheostat position, you have to take L1 and L2. For one rheostat position, move this two-way key towards E1 and E2, measure simultaneously L1 and L2. Now for the same rheostat position, the two-way key is connected towards the cell E2 and calculate the balancing length L2. Now you need to calculate the balancing length L2. So the procedure is repeated again for the next rheostat position. So later, just move this rheostat pointer a little bit at different ohms, slightly you need to vary it. So for that new rheostat position, again this key will be moved towards the cell E1 and measure the balancing length L1. Okay. So later once we write the L1, later you move towards this towards cell E2 and write down the balancing length L2. In this way, for the next reading, again change the rheostat position, then you move this key towards E1, write down L1, then you move towards E2, write down L2. So hence we got three values such that initially you will be getting the values of EMFs, like when we provide the cell to you, like EMF value have been written already. You will be knowing the answer initially. The thing is, the ratio of L1 by L2 should come same as E1 by E2. That is what you need to check here. Okay. So, once we write all those L1 and L2s, take the average of this and write over here. Okay. Hence, we can prove that the ratio of E1 by E2 is same as what? L1 by L2. So, you need to write the calculation on the white sheet on the left side of on the left side in your journal, and write down these all trials, take the average value, then the result average value of E1 by E2. This to be written on the ruled side, means where you have written procedure, below that you need to write at the end, at the last, where there is a signature and all in the bottom part of the journal, just above it in the lines you need to write it. At the end of the experiment result, the average value of E1 by E2 is so and so. Okay. So, this is what the procedure and all, how to make the connections. Okay. So, simply we need to close it, set one rheostat position, find out, move this two-way key towards E1, measure L1, then move towards E2, measure L2. Next again change the rheostat position, L1, L2 you measure it. So, in this way you need to do in three way. So, here are your two cells whose EMF you are comparing by measuring the balancing length. Okay. Now, let us go for demo of the experiment. Start here. Okay, students, let us understand which all apparatus we are going to use. Look at here, first we will start with this. We know already this is a one-way key, here only one way is there. So, one way, this is a one-way key. Look at this, these are two-way keys, means we can use this part also or we can use this part also. So, this is what? A two-way key. Okay. This is two-way key, this is one-way key. This is a jockey, you know already, a pointer which you are going to move on a wire. Then this is a galvanometer where we have symmetric deflections on both the side. What do you mean by galvanometer? Galvanometer is a device which shows the very small amount of current. Here we are going to see the deflections, okay, ampere per divisions. Now, look at here. Next we have a rheostat. Look at this, this is a rheostat. On this windings are there. So, different windings will give the different resistance. So, this is a rheostat, an example of variable resistor which we are going to use in our experiment. Then this is a potentiometer setup. Here we have potentiometer setup. Look at this. This is a 400 centimeter wire. This is a manganese wire, where these two ends you can use either P or Q. You can use this as P or this as Q, anything you can use, because readings have been written here. If I use this as P end, so reading will start from this. So, here 1 to 100 centimeter. So, this is 100 centimeter, means 1 meter wire. Again further reading you need to take in a zigzag pattern, then you need to start from this side, and for the up to here it is 200 centimeter. Then again from here 200 to 300, then from here next here 200 completed, then from 201 next 200 to 300 reading here, up 200 to 300, then from 300 to last we have 400 centimeter readings. So, in this way 1 to 400 centimeter wire it is, totally 4 meter wire or 400 centimeter wire. This is peak end, this is Q end. Okay. This is potentiometer, an extended version of meter bridge I can say. Then this is battery eliminator, we know already. From the KEB supply 230 volt will come, and in this there are some circuits which will convert 230 volt AC to like these voltages 2 volt, 4, 6, 8, 12 DC. Okay. This is battery which will give us voltages. This will help us to energize the circuit. Then we have cells. See, these cells are small voltages, DC voltage sources we can say. So, here this Daniel cell, this construction and what all the Daniels are actually contained, these are not actually Daniel cell and Leclanche cells what they have written here. In chemistry we will be having some chemical type of cells, they are the actual cells. Here we are getting directly the voltage equivalent cells format where we can say. So, this is Daniel cell whose voltage is 1.08 volt. The actual construction in chemistry you are going to see, like the some electrodes will be there, that is the actual Daniel cell, but it is the equivalent form of that. So, for that cell we are using 1.08 volt. From this cell I am going to use what is the EMF now, 1.08. And what is the EMF of this cell? 1.5 volt. See, I am not using this in a circuit right now, so I can say this is its EMF. So when no current is drawn from a cell, it will, that voltage across these two ends will be called as what? EMF or open circuit voltage. This is Leknanche cell. Its content and all you have understood in chemistry. So that equivalent form here we are going to use, which provides the DC voltage or output voltage of output DC voltage 1.5 volt. Okay. So these two cells we are using in our experiment, whose EMF we are comparing to the balancing length. Okay. This is what galvanometer to get the deflection. So hence these are all the introduction of the experiments. Now let us proceed with the connections, followed by taking the readings. Hello students, now let us start the circuit connections. Here we have already potentiometer and all the corresponding devices. Let us start. You people always start the connection from battery, so it will be easier to start from battery. So here from positive terminal of the battery, let us connect it to the P end. So I am going to take a small wire, okay, and you can let us connect the positive end of the battery. Here there is a small hole, or you can tie the wire, just wire it, then connect to P end. I am assuming this has P end, so connect this wire here. Okay. So from battery positive to P end. So this connection I have done. Now let us start connection from P end to the positive of first cell. So I am taking 1.08 and one more is 1.5 volt as cells. Let us put one or the other, it will be easier to have the connections. I am assuming this is E1 first cell, this is E2 second cell, E1, E2, okay. So from the P end, it is connected to the positive of the first cell. So here from the same P end, there is a one more wire which is connected to the positive of first cell. So here is a positive of first cell. So E1, E2, positive of first cell is connected to P end. So I have taken this as P end. So I am going to connect the same wire here. So here I have connected from P end to positive of the first cell is over, and from the same positive of the cell, take one more wire and take the wire from this positive of first cell, take one more wire and connect to the positive of the other cell. Okay, from here. So I am going to choose a very small wire. Here. So these two ends I am going to connect it. Okay students, so here we are going to connect this connection. So once it is done, these two connections I am doing positive to positive of both the cells. E1, E2. So this much connection is over now. Now say this, the negative side. Okay. Right now, say this is a two-way key. Okay. So here we are going to connect the negative of both the cells to this end and this end. Okay. So these two ends are there. We have to connect the negative of both the cells over here, and the center we need to connect to the galvanometer. Okay. So what I am going to do now here is, I am taking the negative of first cell and connecting to this end. And take one more wire and connect the negative of this cell and I am connecting to the other end. So these negative ends are there, no? The small ends. These are connected to the dead ends of this two-way key, and the center of this two-way key. This is what your two-way key. This is your two-way key. The center knob is connected to the galvanometer. Now take one wire for galvanometer connection. I have taken a wire and connect this wire to the galvanometer. Connected the center. Tie this wire here. Once we wind this wire here, just tight it. So we are doing actually this connection, and I am going to connect this to the negative of the galvanometer. Okay, so this is done now. Now what you do? Connect the positive end of the galvanometer to the jockey. So here we have a jockey which indicates the deflection in the galvanometer, which help us to show the deflection in galvanometer, and connect this wire to the positive side of the galvanometer. So once we are done with this, okay student, see up to here we have done. Now coming to this part, Q end is connected to the upper end of the rheostat. Q end is connected to the upper end of the rheostat. So Q end should be connected with the upper end of the rheostat. So here I have a rheostat. Look at this. Here we have a rheostat. Upper end of a rheostat should be connected to the Q end. I am taking P and Q as the ends. Connect this end to here. So this part is over. Q is connected to upper end. Leave this end as it is. Now take this other end and connect to the plug key. So here we have a plug key which is one-way key. Okay. Take one wire. So here it looks complex, but once you come here and will do, it will be easier for you. Just go with the lines. Here the line will indicate the wires. So here I am going to connect that wire. So this is what that connection. This end is connected to the one end of the plug key. So lastly, the other end of the plug key should be connected to the negative of the battery cell. So from the other end of the plug key, connect the wire to the negative of the battery cell. So take the last wire from plug key and connect to the negative of the battery. So here I have taken that wire and connected to the negative of the battery. So this is what we have done the connections. I have not switched on any keys, all the keys are opened. So this is what the connection. I'll just show you with one glance. P side, look at this, positive of the battery is connected to the P side. Okay, and from the P there is one more wire which has gone to the positive of the first cell. Okay, first cell is 1.5, that is Leclanche cell. Here it is written Leclanche cell 1.5, and E2 I have taken Daniel cell 1.08. So from that positive end, connect one more wire to the other positive end, this one, Okay, this is done. And the negative of the first cell, the negative of the first cell connect to the one end of the plug key, and the negative of the other cell connect to the other end of the plug key. These two. These negatives have been connected to the dead ends of the plug keys, two-way key, and the center end of the two-way key is connected to the galvanometer's negative end, and the positive end of the galvanometer it is connected to the jockey. And from the positive end of the other this potentiometer, it is connected to the upper end of the rheostat. This end has left as it is, and the other end of the rheostat it is connected to the one-way key is one side. Other side of the one-way key is connected to the negative of the battery supply. So hence we have done the connections. Now the procedure is, let us start working. So once we switch on everything, after that we need to plug in these keys. Okay. So the procedure will be simple. Like one cell will be using one time, and corresponding balancing length we need to calculate it by one rheostat position. By taking three different rheostat positions, we are going to measure L1 and L2. Okay. Here we are going to start. I am going to switch on the battery. So here I am going to switch on the battery. Okay students, now connections have been done properly. So this is the first step of procedure. Connections should be made as shown in the circuit diagram. Now look at this. Once everything is corrected, first you plug in the main key. One-way key should be on. Okay, now the circuit is completed. Now at one rheostat, randomly I have kept one rheostat position and connect this two-way key towards the E1 cell. Means here the negative cell, first cell is connected to this end, means this side. These two connections I am making and making the circuit path like this. Okay, so first part E1 is connected. I want this connection, so I am closing this. Means I am using only these two connections now. One is negative of the first cell, and the center will be connected to the galvanometer. So now first cell is used, second cell is not used because this key is open. This wire is connected to where? Cell E2. This wire is connected to where? Cell E2. So I am not using that. First I am using cell E1. So this wire is connected to cell E1, right? So I am using cell E1, not E2. Use cell E1 at one rheostat position, write down the balancing line. So look at here, before going to the procedure, write down the EMFs. So given EMFs are, given EMF of this cell, E1 is 1.5 volt and E2 is 1.08 volt. Okay. So what should be my answer now? E1 by E2 is 1.5 divided by 1.08 volt. So what should be the ratio for this? 1.5 divided by 1.08. Okay. So given EMFs are what? E1 is 1.5 volt, E2 is 1.08 volt. So this is Lechner cell and this is Daniell cell. But actually they are not those cells, they are the equivalent, electronic equivalent models. Okay? Because in chemistry we have seen electrodes and all, they are the real cells. These are equivalent model of those cells because output 1.5 and 1.08 is going to get from those kind of cells. Okay? So let us use it, and I have given the given values. E1 and E2 are these voltage values, E1 by E2. See, the speciality of second PU lab is before doing any experiments you will be aware about the results and you should get that kind of result. See, E1 by E2 is how much? 1.5 divided by 1.08 is 1.38. This ratio answers should come nearly 1.38. Okay, by taking the ratio of L1 and L2 it should match your answer 1.38. So I am going to calculate the balancing length L1. Rheostat is kept at one position and cell E1 is used because this circuit is closed. Now check for opposite deflection. This is P end, this is Q end. PQ, the length between PQ is 400 centimeter. So keep the wire at here. Opposite deflection. If I am keeping the wire this side, it should show opposite deflection. And if I keep the wire on the other side, it should show on the either side. So this indicates that our connection is proper. Now let us find out the balancing length L1 for the cell E1. So move your wire randomly where you are getting a balancing. Up to here it is 100 centimeter. From here it will be 100 centimeter plus. So where you are getting balancing this length, that length you need to calculate. Balancing length means what? The length in the potentiometer where the galvanometer shows the zero deflection. So this length I am going to calculate. Where it is showing accurately zero deflection, that length we need to calculate. So next 200 plus it is. Just to check where you are getting zero deflection. So here it is fluctuating, take slowly. Okay. So here I have got the values. Zero deflection in the galvanometer at what length? See up to here 100 centimeter, then 200 centimeter, 200 plus up to here. It is, look at here, this is 285.5. You can see here this is 285.5. So this reading will be 288. This is 88 no? 100, 200, 200 plus 288.5. So first L1 will be 285.5. So 285.5 first L1 we got. Now students, find out length L2 for the same rheostat position. Just remove this key and plug in on this side. If I plug in this side now cell E1 is not used, cell E2 will be used. Okay, cell E2 is used because this side connection we have made now. So the circuit will be like this now. Okay, E2 I am using, not E1. I have removed this key and connected over here. Now let us find out, check for opposite deflection. Okay, it is working. Now find out the corresponding balancing length L2. So here if I go here up to 100, then 100 plus. Just go on moving and take one constant value. The galvanometer should not deflect. Okay, here I am going to get one value. Look at the galvanometer, it is showing zero deflection. Okay, it is zero deflection now. See the reading now. The reading is here, next reading is 295. It is, sorry, not 295, just 95. So up here to that dead end 100 plus. So 194.5. This reading is 194.5. This is pause. The first reading we got around 1.4. So 1.38 is the answer. So it will be equivalent to 1.4. So nearly we are getting. Okay, that is what the purpose of practical. You won't get direct results. You will get the nearest answers. Okay. So now let us go for the next trial. Next trial is just vary the rheostat little bit. Little bit you vary it. Then start the same procedure. Plug in this key to again cell E1. We are using cell E1, not E2. Measure the balancing length. Go for this and come back. Where you are getting zero deflection, that length you need to calculate. Come slowly. Okay, just see here Here we got zero deflection in the galvanometer. Here we got a zero deflection in the galvanometer. Now let us write this reading. So the reading is up to here 96, next 97. It is 297. So here I got 297. Now let us write down the next balancing link. Connect this plug key E2 side because this wire is connected to the down E2 cell. Now measure again L2 length. Look at this. You need to vary this until you get zero deflection in the galvanometer. So here somewhere we are getting, see that galvanometer. So if there is a loose connection somewhere, the galvanometer will deflect. So slowly you need to take. Okay, look at this. So around 2, so look at this reading. Here we got a zero deflection at what length? So up to here 200 completed, then 200 plus 209, 209.5. So the second reading is 209.5. Now take the last try, just vary this rheostat little bit and go for even connection. Get the value of balancing length again E1. Okay students, I have taken 3 different readings for 3 different rheostat position. Keep one rheostat position, take E1, measure L1, then take E2, measure L2. In this way you have to repeat for 3 different, slightly you need to vary 3 different rheostat positions. Write down the balancing length, calculate the ratios. Look at this, our EMF, the ratio of given E1 and E2 is 1.38, which is nearly equal to 1.4, and from our experimental setup the ratio of L1 by L2 should match with this answer, so that we got 1.43. So hence we have successfully done this experiment. Just observe the how I done, how you need to take the readings, followed by very small trial calculations you need to do. Trial number 1, write down L1 by L2, then trial number 2, 3. At the last, write down the result on the lining side, rule side, where you have written procedure. Below that, write down in the rule side only. Result, the ratio of EMF is like this. Okay, experiment is completed. That is comparison of EMF of the 2 cells. Thank you.